Hello and welcome to another free code session. My name is Jason Bach and I've been editing some videos for the past couple of days, and I noticed that I always have this glare on this eye from that light over there. So I'm going to try to fix that in the next one and maybe put the light above me or somewhere, somehow diffuse it. It is a little diffuse, but it's still a little bit too bright on my glasses. I could just do this if I could if I could see my screen without reading glasses, but I can't anymore. So it's a Friday night, and what do people do on Friday nights? They code, right? Who doesn't code? I'm gonna try something. This might be a very short video, it might not. Those famous last words, I don't know, but I want to try something here. Let's actually do this. And yeah, 30. I'm getting into the bad habit of doing just dumb old incremental console apps rather than actually having an app. I don't know. Maybe I'm getting older. I'm not sure what it is. But here's the thing I want to do. So this past week I was in VS Live Las Vegas, and I was adding some demos over the past couple of days for it. And one of the demos I did was saying, hey, if you've got a bunch of work to do that's CPU bound, and you want to say, I want to do this work from A to B. Well, we have ranges now in C# 8, so that's awesome. And that reminds me, I should do all the things with the stuff here and update them so that I have lang version is latest. And yeah, let's make sure nullable. Oh, come on. Nullable, enable. And of course, we must always treat warnings as errors is true. Okay, so what I wanted to do was have a way to say, split that across different tasks, essentially different threads. So I had to have an even or as evenly possible partitioned set of ranges. So for easy example, if I have 0 to 100 exclusive, because remember ranges are always exclusive, and I want to split that across 4 cores or 4 partitions, well, that's easy. You go from 0 to 25 exclusive, 25 to 50 exclusive, 50 to 75 exclusive, and then 75 to 100 exclusive. Easy. Okay. But if you start doing like 100 divided by 7, well, then how do you distribute that evenly across them? Okay. Well, I found an algorithm to do it. It's really not that hard. It's this. Okay. And so what we're going to do is take this code, because I think I can improve upon it just a little bit. Okay. So we're going to say add class range partition tests. Okay. I'm going to do that, public class, benchmark, all the things. I saw an article today where somebody was talking about benchmarking stuff. Oh God, that was stupid. Better not have. Yeah, go away. Benchmarking stuff without using the benchmark.net framework. I'm like, why would anybody do this? It makes no sense. None whatsoever. Okay, so I'm going to throw this out here right now. We'll change it to a this or that. Come on, you got to know what a range is. Yes, you do. Okay, so what this does is it says, okay, find the highest length. Well, that's just your partition size, if you want to call it that way. Okay, and then it finds what the size should be of each bucket. Okay, because first what it does, it'll say, well, you want to say split it across 7, okay? And then fill these bucket size with the highest length, okay? So that would be, for example, 100 divided by 4 would be 25, okay? So each of those are going to be 25, 25, 25, 25. Now your surplus is, if you went from 100 to 0, that would be, this is actually interesting. If I say the end value, which is the exclusive end of the index, and this is the exclusive index. So this is kind of interesting because I think there's a little bit of a bug here. If I say 0 to 100, I actually want to say, yeah, I don't actually want the plus here, if that makes sense. Okay. Because why is that? Oh, yeah, we got to think about how to do this. Okay. Right. So what this should do, okay, so we get the number surplus. So if we have 100 minus 0, that'd be 100. Mod 4 would give you 0 because there is no surplus. And then you just don't go through this while loop. Okay? Then you build your ranges based off of this, and off you go. The thing that I thought is, I don't think you need to keep the bucket sizes for each one. I think there's a way that you can calculate it so that you have all this information as you need it when you're going through this for loop here. I think there's a way to do it. Okay, so if you have a range of 1, you just return the range. If you have the number of ranges is 2 or above, this may not make as much difference. But if you have a larger number of ranges, then you don't have to keep like an 8-element array around. So the memory here won't be that big of a deal. Okay, but it's worth trying. So the first thing I want to do here is say var ranges is equal to new range partition tests partition, and our range is going to be 0, 100, and then we're going to say 4. Okay, and then for each var ranges console. So I just want to make sure I'm doing this right. Make sure we're in release mode, and we are. Okay. Run. So we get 24, 20. Yeah, that's not quite right either. That should be 0 to 25. Maybe that was supposed to be. Okay, that looks better. But that's off now because the first number should be yes, I guess I got a bug in my code. The first number should actually be not, how do I say this? So this is the simple case. So I'm trying to debug something I want to get rid of anyway. So the k is the start value, which would be 0. Then 0 plus the bucket size, okay, which would be 25. Minus 1, so what we're seeing is 26. That doesn't make it. If it's 100 minus 0, you have 0 plus 1 is 101. You know, let's actually check this out because let's make sure this is actually working the way I expect it to. So we have end value of 100, start value of 0. The highest length should be 25. So we fill the bucket sizes, and they should all be 25, which makes sense. The surplus should be, see, we have 1 here. There shouldn't be a surplus. I think that's what's throwing us off here. And this is wrong too. I mean, 100 minus 0, 0 is 1. It really shouldn't be that because we are exclusive here. I think this is assuming an inclusive. So let's first of all solve that. Okay. And then let's come down here and say that this should also be that. Okay, so now if we do this, we should have a surplus of 0, which makes sense. So our bucket sizes should all still be 25. Okay, so now our one is, okay, that makes sense. So now we want to do a new range. Actually, what's interesting here is I could probably just say that value dot dot that value. Okay, but what we want to say is 0, 0 plus 25 minus 1. I think that's the problem because these are the exclusive values. So if I say here that, okay, now what happens? And now I get 25, 20. That makes more sense. Okay, so actually what I could say here is k dot dot, well, I don't know if this is going to k plus bucket sizes of I. And then we just say that. It does. Okay, that makes sense. That's weird syntax. Yeah. So the C# developer, that's very weird syntax. But it works. Okay. So, and then the K, you just keep saying, well, how much that should have been is where you push it to. Okay, so if we run this now, we should see that. If we just decide to say, you know what, we want to actually go up to like 5, we should see 5. Yep. If we say 7 here, then, you know, each of those is, see, that's 15. You know what we should do here is say range, and then we'll say range end value minus range start value. Yeah. So if we go back to 4, what we should see is 25. If we do 5, we should see 20. And what if we do 7, they should approximately be close. See, there's 16, 14, 14, 14, 14. That's not necessarily right. What it should be is 15, 15, 14. Yeah. Excuse me. You have to distribute that value a little better. Okay. But even that's not the big problem. You know, if you see here surplus, see, in this case, surplus is going to be 2, because 100 minus that, you know, if I do calc, because I don't trust myself, 100 mod 7, it's 2. So we have 2 here that we have to get rid of. So we want to say the bucket of the surplus index is that. And now we want to, see, we should do plus plus, that's the problem, I think, is that we don't say we post index it, I think. See, now if we run it, so now we get 15, 15, 14. Okay, that makes sense. And then if we did like 9, then we see the first one gets, okay, that makes sense. Yeah. All right. Okay. So, you know, this is fast-ish. I don't know how fast, though. We're going to find out. But I first want to say, hey, can we do this so that we don't have to keep an array around? All right, so we're going to say benchmark public mutable array of ranges partition with no array. So we take a range, and let me say partitions. So I'm going to change this to range and this to partitions. Okay. So the first we want to figure out is the range size. That's essentially this. Okay, but we're going to rename it range size. Okay. Now, I had this algorithm here. So the range R divided by the number, the size of the range R, divided by the number of partitions P trimmed gives you the minimal range amount for each partition. Okay. So basically what we're saying here is this, because I think this should cut it off in that it gives you the minimal. Okay. All right. So we got that. And of course, I'm not doing things like checking for, is the end greater or less than the start? I don't care about that. I don't even know if you could do that with this, if you can reverse them in C#. I don't remember. It doesn't matter, though. What happens if you say 1? I'm more curious about getting rid of that array. Okay. The remainder is the amount that needs to be sprinkled across the partitions as evenly as possible. Okay. So 113 across 5 means 3 is a remainder, so it's the mod. Okay. We're just going to call remainder for now. So it's the we're going to call this this we're going to call for the range, because this is is equal to that. Okay, and we can get rid of unnecessary parentheses. And then here we're going to say range size. Here we're going to say minimal range, minimal partition size. Okay. And then we're going to say the remainder is the range size mod partitions. Okay? Alright, so we got that. We're doing good. So you take that remainder and add 1 to each range being created, and then subtract 1 from the remainder. Once the remainder is 0, you no longer have anything to sprinkle. So now what do we do? Well, we're going to say k is a start range, so we're going to say k plus the minimal partition range size plus, if the remainder is actually greater than 0, we do 1, else 0. And then we say k is equal to, so we're going to actually capture this. Var partition range is equal to that. Okay? Because we need the upper thing we just calculated, partition range. And then we're going to say k is plus equal the partition range end value. Okay? And then we come out with all the partitions. Now, we have to subtract this, though. But we only want to subtract if it's, we only want to subtract, I feel like I'm doing it twice. That's the problem. I want to say remainder is equal to remainder greater than 0. If it's greater than 0, you need to say remainder minus minus, otherwise 0. Which feels kind of yucky. I'd like to get rid of this somehow. I'd like to, I'm just not clever enough right now. But I think this should work. If I say partition with no array, if I say 4 here, that's right. If I say 5, that's right. If I say 7, that's completely where the heck did that come from? That one completely screwy. Let's check that one out. Okay. Actually, you know what? I have a test case here. So let's do 101 across 8. Yeah. So I already figured that one out. So 101 across 8. Okay, so the range is 12, the minimal range is 12, and the remainder is 5, right? So the range size is going to be, oh yeah, so the minimal is going to be 12, yep, and the remainder should be 5. Okay, so we do ranges. Start at 0, right? And our partition range is going to be 0 to 13, yep. K plus equals the end value, so that's going to be 13. If the remainder is greater than 0, we're going to say remainder minus minus, otherwise it's equal to 0. Oh, well, I think that's you gotta do it pre. That still's not right. So, I think this is all good. We just got to get down to this point. I will see it once it happens. So, okay, is that? Remainder should be 4 now. So what do we come into here with? K is 13. That's the minimal partition range. If it's greater than that, so we should see 13 plus 26, right? Which is fine. We add that. We get the end value. Remainder is now that, so we should see 3. Okay. Partition range is now 3952. Wait, which one are we on? Wait, how many? We've got 2 in here. 26. How do we get to 39? Wait a minute. Oh. In this case, it's equal to the end value. Yeah. I think. $77.89. Does this look right? So 13, 26, 23, 39, 52, 52, 65, 65, 67, 79, 89, 101. And yeah, that looks exactly right. Okay, so let's just make sure though, because I thought this was working with that. That does. That does. And that does as well. Yep. Okay, so this seems to all work now. It seems like we've got the right logic for both of them. Now the thing is, though, is I want to, this is why I had to bring this up, because I needed to do, how do we do intro params? Because what I want to do here is say, I want to produce a bunch of ranges and a bunch of partitions. And just, I'm not really concerned too much about, again, the accuracy of it. They seem to be the same. What I'm more curious about is one faster than the other? Okay, so let me just check this out because there's a couple ways to do this. I don't think you can put, like if I say here, if I come back here and I say like public, what do you want to call this? I don't think you can put tuples in a attribute value. I'm going to find out here. But if I say, yeah, you can't, it doesn't know it's a range. Because you want to say range. Public range int partitions. And then you say get set. Okay. Now I want to say here like params, and then you just do 0, 100, 4. Yeah, it does. Well, okay, I got to do that right, but it's not going to take that. Yeah. Yep, it's a constant expression, so that's not going to work. And then it kind of expected that. Okay, so what I need to do here is like a param source. Okay, so I'll still keep this as source. Okay, but now I need to say where are the values actually coming from. Public IEnumerable of range int values for partitions. Okay. And then here we say yoink name of that. And because I'm a picky pants, I like to be that. Okay, so that should give you the name of that. Okay. And then here I can say yield. I don't need to, I could, yeah, just do it as a new. Okay, and then I can have in here 0, 100, 4. Does that not look bizarre? 7, we could do something like 255 to that across 23. You know, we're going to have a couple values here. Okay. So, we're going to take this out here. And that okay, because it'll go through that, set it that, and then you call that. So what we need to do here is say var. Okay, we're going to take this off here. No, I'm going to sort of capture. We're going to yank that, except we're going to do that, but we don't need that. We're going to say range partitions is equal to this dot partitions. There. Perfect. Perfect! Oh, that's so beautiful. Okay, and then we can come down here and do the exact same thing. We can say that, and I'm going to say this one is going to be the baseline. Okay, and that's going to be true. All right, so moment of truth. Does this bench mark runner.run of range partition tests? Does this work? Is this actually going to give us something that's faster or slower? So, if it starts running, I'm going to, I'll pause the video. Well, I'll come to the end when we see the results. So, take your guess. Which one's going to? I have no idea. I'm not like setting this up, but take a guess. Which one do you think is going to be better or worse? And again, I think I mentioned this at the beginning of the video. I saw a article today that was talking about benchmarking. They didn't use the framework, but they also, I think, came to a kind of a somewhat bad conclusion. It's this thing I saw on the internet where if you have a class that implements multiple interfaces, the one that you think it's going to get cast to should be first in the list. Because there's a slight performance help there, but it's like really, really minuscule. But he did his article showing, oh, it's like 2, 3, 4 times better, but he was typing his variable as an object, not as the class type. And as I found out, that actually makes a difference. So, not only do you need to use benchmark.net, but you really have to question yourself and going, am I testing the right thing? Or what am I really testing? So we'll see. I think I'm testing the right thing. So we'll run this and see what we come up with. Yeah, you got to be in. It's like, am I still in release? I am in release. Okay. Let's just run this now and see if it actually kicks off, and hopefully it doesn't give any errors. You're thinking. You're kind of building. You're sort of, okay, off you go. All right. Come back when it's done. And we are back. Okay, so which one is actually better? It's interesting because you see the ratio here as like 4 and 7. There was a slight difference. There really isn't a difference here, though. I mean, it's very, very slight. I'm gonna probably run this again because I want to see if I throw in a couple of other ones what it does. What is interesting to note, though, is the allocated stuff is slightly better with the no array one, and that makes sense because you at least are, in this case, you had to allocate an array of 23 integers. In this case, you don't. The only things you ever allocate are, if I come back here, are, well, you have to get your original, what your range of partitions are. You have to do this, which these are kind of things you have to do anyway. There, you avoid an array fill, which is kind of interesting because that doesn't really even seem to matter here. What's also interesting, and I didn't notice this before, is can you give it, your initial capacity? I already know what that is. Okay, and I'm going to cheat here because I didn't notice it here, but I do here. I know exactly how many I'm going to have. I don't need to guess. And I'm kind of guessing here, okay? What I could also wonder if I say ranges, can you gets or sets? Yeah, because you're in a builder, so you could say ranges of I is equal to your partition range. Okay, you don't have to add it. You know what it is. So that's also interesting. I'm going to run this before I go off and try, more. Well, you know what? That's okay. Let's do that. Let's just come in here and let's put in like some come on. We're going to do 427. I'm going to say 7. Okay. And then we're going to do 2 through 4, 8, 9, 6, that. We're going to do 645 partitions. Just some ridiculous numbers here, which we should find, hopefully some differences. So again, I'm going to run it, and we're going to see if those couple of changes been any difference. What else did I want to come in here? Oh, this too. I really want to. I'd love to find a way to say, figure this both out in one shot rather than doing this. But we're going to kind of leave that there because I don't know if that's really that big of a deal. So let's run this, and I'll come back when all the results are in. Houston, we have a problem. Whatever I did in here busted something. So I'm going to have to come in here, debug. Okay, then we're going to, come on. And then we're going to do that, except we can't do that. But what we can do is say, yeah, that's fine. And then we can say this partitions is equal to 0, 100, 4. Oh, that would have been fine. And then we can say that. Okay, and then we've got that. Okay, that's fine. That'll work. So what happens in this case? So you do that, that, that. That should all be fine. Ranges. You get a partition range. That's 25. Index was out of the bounds of this array. Oh, really? Well, ain't that cute? I guess that's my bad assumption here. Create builder. So what happens when you have the initial capacity? The initial capacity of the builder. Okay. So I guess we just say add that. And then that should give us back what we had before, right? Yeah. Okay, so that was the only problem, is that I was assuming when you said to the builder that you had a capacity that then you could index into it, and it was actually of that length, but that doesn't seem to be the way it works. I'm still going to keep that there because I wonder if that at least gives it a hint as to say, well, you should only go up to this size. But either way, I was wondering, I had no memory allocation right, and then I was like, what? And then I saw this, I'm like, oh, I had an error. So build configuration manager release one more time with feeling. One more time with feeling. All right, we are back. And now I can see there's, in these cases, there's definitely a difference. So we're seeing 25%, 22%, twice as fast. And I think that would also vary depending upon which number you hit or something like that. But it's also clear, when you start getting into partitions where you've got, like, what is this in this case? What is this? I can't tell what that. I think this is saying 427. This is, oh yeah, that's higher. So obviously the more the size of your array grows, the larger you go. And this also will just happen because you are allocating more ranges. But this is definitely faster and less memory. And maybe I could even get a little bit quicker. We'll see. But this has been good. And you might wonder, why am I still doing this? Well, Spackle, my little handy-dandy library, which is running out of things that it can do, it does have a range type. And I think I mentioned this before. I need to think about, how do I either keep it or get rid of it? I think my range type is actually generic, and that you can just say it's a range of any type. And do I really need to keep it around, or do I just say, hey, this is going to become obsolete, and then eventually it's just going to be range? But I want to add some range extension methods. This is one of them. I think this would actually be pretty helpful, is to have a way to just say partition a range across X number of partitions. And that's why I wanted to do this, to see if there was a way to improve that original idea. And it looks like there is. So I might do a video on adding this in the Spackle, or I might just say screw it, and not do it. We'll see. But this has been a fun excursion, and it's been fun to do this on a Friday night. So that's all I'm going to do in this video. Thank you all for watching. Leave comments and questions below. I'll see you in the next video.